Hey everyone, today we're going to be doing a related rates calculus problem. So this problem starts off with the surface area of a sphere is increasing at a rate of 14 square meters per hour. At a certain instance, the surface area is 36 pi square meters. What is the rate of change of the volume of the sphere at that instance in the cubic meters per hour? Okay, so they first talk about surface area and then they also talk about volume. So we'll bring in those equations right away. So surface area is equal to 4 pi r squared, and volume is equal to 4/3 pi r cubed. Okay, so the problem starts off with the surface area of a sphere is increasing at a rate of 14 pi square meters per hour. We can translate this to ds over dt is equal to 14 pi square meters per hour. At a certain instance, the surface area is 36 pi square meters. So we can translate this to be the surface area is equal to 36 pi. So we have 36 pi as the surface area. And then while we're at it, we might as well solve and find the radius, because now we have the surface area and we can use our surface area formula to find the radius. So starting with 36 pi is equal to 4 pi r squared. Dividing 4 pi from both sides, we get 9 equals r squared. And then the square root of both sides is plus or minus 3, but radius can only be positive, so we take 3. Thus, r equals 3. And now we can go ahead and start finding the change in volume with respect to time. So to do this, we'll take the derivative of the volume formula, where we can basically use the power rule and bring the 3 down. So then we get 4 pi r squared times dr dt, so radius with respect to time. And then we can start plugging values in. Since we know the radius is equal to 3, 3 squared is 9, and 9 times 4 is 36. So we can say dv times dt is equal to 36 pi. And now we need to find the derivative of radius with respect to time. To do this, we'll take the derivative of the surface area formula. And because we already know what ds, the derivative of surface area with respect to time is. So then this will give us the derivative of radius. So solving for this, we can do the derivative of surface area over time is equal to 4 pi, dropping the 2 down, we get times 2 r times dr dt. Since we know ds a over dt is equal to 14 pi, and r is equal to 3, we get 3 times 2 is 6, and 6 times 4 is 24, so we get 24 pi times dr over dt. And dividing from both sides, we get 7 over 12 is equal to dr over dt. Substituting this back in, we get 7 over 12, and then dv thus is equal to 21 pi. Because 36 divided by 12 is 3, and 3 times 7 is 21. And so now we just have to worry about our units for this problem. So volume is usually represented with centimeters and centimeters cubed, so we can start out with centimeters cubed. And then time in this problem, it's actually in meters. Okay, so we have to look a little bit closer. It's in meters, so it's meters cubed. And then now we need to find the time units. It looks like the time units are per hour. So we can take the per hour and we can say 21 pi meters cubed per hour, and then that is our answer. Thank you for watching.